Today we're looking at functions part 2, where we're focusing on additive relationships. So relationships between the two quantities x and y is not always going to be proportional like we were seeing previously. Their relationship could be additive, and that means that the quantity y is a result of adding a value to the other quantity x. So an additive relationship can be represented with the equation y equals x plus b, where b is called our y-intercept, or that's where it would be crossing the y-axis. So we kind of talked about the word intercept. Sounds like intersection. So where two roads cross, that's where they meet. So a y-intercept is where our line will meet the y-axis, and that's going to be where they cross. So then we have the y-intercept is the coordinate 0, b, where b is not allowed to equal 0. Therefore, additive relationships are not proportional because their graphs will not cross through the origin. So previously, all the graphs that we saw that were proportional were crossing through the origin, and now we're going to be seeing graphs where they don't go through the origin, so that means they won't be proportional, and their y-intercept won't be the origin anymore. It'll be any other point on the y-axis besides 0, 0. So that's why we said b isn't allowed to be 0 on the graph. So the y-intercept is allowed to be positive or negative. If it's negative, then our equation is going to look like y equals x minus b, but the general rule is y equals x plus b. So in order to write an equation to represent a relationship from a table, first thing you want to do is find the difference between x, y, and x, and then in each pair of x, y values, if they have the same difference, then there will be an additive relationship with a slope of 1, and if the difference, or that difference then can be used to write the equation y equals x plus b. So the first thing we want to do is make sure that this won't be proportional, and we also want to find what the slope is. So remember, to find the slope, we can figure out, okay, we're adding 1 to all of our y values, and then in all of our x values, we were adding 1 as well. So that means the slope of this line that we already know how to find is 1 over 1, or just 1. So we previously were saying, well, if it was going to be proportional, then we'd know that the rule for this line was going to be just 1x. But we don't know if this is crossing through the origin yet because we haven't checked to see if it's proportional. If I wanted to check to see if it was proportional, remember we would check y over x. And if I did that right now, I would have 12 over 3, which is 4. And then I would check my next one, which is 13 over 4, and that does not equal 4. So we already know right away that this isn't proportional, so that's telling us it's not going through the origin. So that's when we want to test out to see what the difference between y and x is, to see how much we were adding each time to go from x to y. So the difference of y and x means y minus x. So I'm going to do 12 minus 3, 13 minus 4, and 14 minus 5. The difference between all three of those is 9. So that means that if I wanted to figure out what y is when x is 0, and I am realizing that I have this pattern of I'm adding 9 to all of my x's, then that means my y value would have to be 9, because I went from 0 to 9, and then if I was going to do another point, I could have 1, 10, I could have 2, 11, and that would follow our pattern with 3, 12, 4, 13, and 5, 14, and so on. So that means that the difference between all of our x's and y's was 9. So our y-intercept will be the point 0, 9. And we use the equation rule now, y equals x plus b. Our y-intercept is b. So that means we're going to write our final equation here as y equals x plus 9. So that's our final rule for this table. And now notice, we thought it was going to have a slope of 1. Well, 1x, we know that means the same thing as just y equals x. So we were right with the slope being 1, but we just had to figure out, well, what's our y-intercept? So whatever you're ending up adding on to x here is just going to be where your graph will cross the y-axis. So if you want to try it on this one, go ahead and pause the video. Otherwise, just keep watching. So again, we need to figure out what the y-intercept is here. So we first want to check to make sure this is, or what the slope is. So to find the slope, remember, we're going to do the difference in y values. So this was 3, and this was also 3. So if I do my slope of change in y over change in x, that's 3 over 3. So that means the slope of this table is going to be 1. but we still have to figure out what the y-intercept is. Because we don't know what it is yet, we want to go and see, well, what's happening between between x and y. How are we getting from each x to get to each y? So my first y value here was 5, and the x value that went with it was 9. 5 minus 9 gets us negative 4. We can check another one. We have 8 as our y value, and 12 was our x value. So that's going to be negative 4 as well. We can go ahead and check the last one. 10 minus 14, again we're getting negative 4. So for each of these differences between y and x, we're getting negative 4. So that means if I plug in negative 4 as my y value here, negative 4 minus 0 is going to also equal negative 4. So that's telling me that my y-intercept, or my b value, is 0, negative 4. So again, we're going to use the equation. So we have y equals x plus b. So this time, our slope we know is 1, so we could write it as 1x if we wanted to. And then we're going to be adding our b value, which is negative 4. So you can leave your equation in this form, or you can remember that 1x is the same as just x, and if you add a negative, that's the same as just subtracting. So either one of these would be a good final equation. However, you're most likely going to see it in this bottom one, where we just have y equals x minus 4. And you could read that and tell us that the slope is 1 and the y-intercept will be negative 4. So I want you to pause the video and try doing these two problems. When you're ready, you can press play. So our difference in y and x here is 0 minus negative 3, which is just positive 3. We have 3 minus 0, which is 3, and 7 minus 4, which is 3. So the difference of y and x here was 3. The slope was 3 over 3, so the slope again was 1. And then it wasn't proportional because we knew that we have this point 0, 3, so that the y-intercept is actually given to us in the table right here, and we know that our y-intercept is going to be 0, 3. So because our slope is 1, we have y equals x, and then we have a positive y-intercept of 3, so y equals x plus 3 is our equation. When we check this last one, our slope is, we have adding 3 here and adding 3 here. So again, our slope is 3 over 3, or just 1. And then we want to check our y minus x. That's 5 minus 7, which is negative 2. 8 minus 10 is negative 2. And 10 minus 12 is negative 2. So it looks like to get from x to y, all we were doing was adding 2 to these, subtracting 2 from each of these x values to get to y. So our difference there was negative 2. So that means our y-intercept is 0, negative 2, and our equation would be y equals 1x, or just x, minus 2. Remember, we could also write it y equals 1x plus negative 2 if you want to. Okay, so either one of those would be fine. So then sometimes they'll ask you to have, you'll just get these words of a line is passing through some points. So what's the equation of the line? So we want to figure out, without using a graph here, how we could figure out what the equation is. So something I would suggest is just put the values that they give you into a table like we just practiced, if you feel comfortable with that, because it'll be the same idea that we just did. So 2, 8 is one of our points, and 5, 11 is another. So you can decide what's the slope from here. So from our table of values, the change in y was plus 3, and the change in x was also plus 3. So you know your slope is 3 over 3, or just 1. Now we want to figure out the difference between y and x. So we want to figure out what's y minus x each time. So we have 8 minus 2 and 11 minus 5. Both of those get us a difference of 6. So that's going to tell us that our y-intercept, or b value, is 6, or if you want to write it in the point, it would be 0, 6. So for our final equation then, we know that our y equals 1x, or just x, plus 6 for our y-intercept. Now the other way you can do it without writing it just in the table is if you just want to mark these points as xy and xy, you can just find the difference between them right away. And that would be 4 minus 9 or 5 minus 10. So those are getting you negative 5. So your difference there would be negative 5, or you can write your y-intercept as 0, negative 5. Now you want to still check your slope to make sure that that is going to be a slope of 1. So your y value was 5, and then your next y value was 4. So that was just adding 1. And then you also had an x value of 9, and then you went to 10. So your slope is 1 over 1, or just 1. So that means we can write our final equation as x minus 5. I'm going to set the last one up in a table because I think that that's a little bit more easy to see what these values are. So I'm going to take those points that they're giving us and plug them into a table. So I have negative 3, 6 and 4, 13. My slope here is plus 7 on my y, plus 7 on x, so that means slope is 7 over 7, or just 1. My difference between y and x, I have 6 minus negative 3 and 13 minus 4. Minus a negative is just like adding, so we have 9 for both of these. That means that our y-intercept is going to be 9. And so we can write our final equation as y equals x plus 9. Our slope is 1, and we cross the y-axis at positive 9. Now this is going to look similar to when we were dealing with this in proportional relationships. The question says to use the equation given to evaluate the point x, y, then simplify the equation. So you want to figure out whether or not the point is on the line. So they are telling us that the line rule here is y equals x plus 5. So you want to plug in your x and plug in your y and see if it makes a true statement. So my y value here is negative 20. I'm bringing down my equal sign, plugging in my x value of negative 4, and I need to add 5 to it. Negative 20 equals 1. That is not true. So that means that this point would not be on our line. So we check our next one. We plug in our y value first, equals our x value plus 5, and negative 2 does not equal 8, so no, this point is not on our line. My next y value is 11. I plug in x of 6. 6 plus 5 does equal 11, so yes, this point would be on this line. And in our last one, y is 4, negative 1 is x. When I add those together, 4 does equal 4, so yes, this point would be on the line. So you can pause the video and try the other ones. This should be pretty familiar from what we've already seen. When you're ready, press play and then check your work. When we plug in our values here, remember you take your y value first, so 8 is my y value. I plug in x, which is 6. 6 minus 2 is 4, so this is not going to be on our line. Again, 5 equals 7 minus 2. 5 does equal 5, so yes, this is on our line. We have y of negative 18, negative 9 is our x, but negative 9 minus 2 is negative 11. So that is not on our line, because they are not equal. And finally, we have 14 equals 16 minus 2, and 14 does equal 14, so that means that yes, this point is on our line. In our last problem, our rule is y equals x plus 7. So if I plug in 14 for my y, 7 for x plus 7, 14 equals 14. So yes, that is on our line. We have 13 equals 6 plus 7. And yes, 13 does equal 13. So we have another point on the line. 11 should equal negative 4 plus 7. But negative 4 plus 7 is 3, so that does not work and will not be on our line. And then our last point, we have 5 equals negative 12 plus 7, negative 5. And negative 5 does equal negative 5, so this last one will be on our line. So you want to make sure you plug in all of your x's and y's very carefully. Remember, they are in the order x, y. So just be careful as you're plugging those in because that's where people make the little mistakes there.